Mr. Raman, it's an honor to finally meet you.
Oh, the honor is all mine, Mr. Planck.
Your Raman effect has made waves across the scientific world. I must say, it's truly remarkable.
Thank you very much, sir. It means a lot to me. But I must say, without your work, mine wouldn't have been possible. You deserve just as much credit.
What nonsense. You made the discovery, the credit is all yours. The funny thing is, I wasn't even sure I was on the right track when I proposed my theory.
Sir, if you don't mind me asking, what was it like while you were formulating your theory? I imagine it must have been thrilling.
Actually, I was quite unsure at first. You see, in classical physics, the Rayleigh-Jeans law predicted that an ideal black body would emit almost infinite energy at the higher frequencies. This was known as the ultraviolet catastrophe, and so that's why the Rayleigh-Jeans law failed at the higher frequencies. On the other hand, Devine's law, which was another prominent theory at the time, failed at the lower frequencies, predicting almost zero energy at those frequencies. However, actual experimental data showed that energy levels are hardly present outside of the visible spectrum. The energy peaks at this spectrum and then drops off. So, make the assumption the particles in the core of the black body, which are known as oscillators, cannot emit radiation continuously, but rather they emit radiation in discrete quantities, which are known as quanta. So, this concept helps solve the problem of infinite energy at higher frequencies, after which I gave my formula E energy is equals to H, which is the Planck's constant, into frequency. And so this was the mathematical fix, long running problem of the black body radiation.
We can see from this experiment how the glow stick on the right, which is kept in nearly boiling water, glows brighter than the glow stick on the left, which is kept in ice cold water. This shows how the glow stick, which is in a higher energy medium, emits light of higher frequency, a clear demonstration of Planck's concept.
Now this theory solved the math, yes, but I wasn't quite sure it was right. After all, I was challenging everything we believed about energy thus far. I was challenging a nearly perfect understanding of the physical world. Other scientists were skeptical at first, but when some of the world's greatest minds like Einstein, Bohr, Schrödinger applied my theory to real-world phenomena and the results worked, I realized that my theory had real merit.
Outstanding. What an incredible journey. Your Nobel Prize was well deserved.
Well, I've shared my story. Now it's only fair you tell yours. They're Nobel laureate too, after all.
Certainly. You see, on a return voyage from London while sailing through the Mediterranean, I found myself wondering, why does the sky look blue? The Rayleigh scattering experiment showed how when light bounces off of molecules, there is no change in the energy. But that didn't feel complete to me. I suspected that light must have had a deeper interaction with the matter. Hence, once I got home, I decided to investigate on this on my own. However, during colonial times, the Britishers didn't really give much recognitions to Indian researchers, and I wanted to show that we are just as capable.
I built everything from scratch. My student K.S. Krishnan and I passed monochromatic light from a mercury lamp through various substances. The lenses, filters, and even the spectroscopes we used were handmade or improvised. We spent days adjusting and tweaking the setup. And finally, we saw it. The frequency of light had shifted. The change proved that light interacts with matter in a new way.
It wasn't just a personal breakthrough, it put India into the global scientific spotlight.
Incredible! Your creativity and perseverance is truly inspiring. Such determination truly earns its rewards.
You're too kind, sir. I only wish to bring my country the respect it deserves.
All this, equations, theories, is fascinating, but often wondered, what gives science its true value? Surely it's about how it's applicable to everyday life.
Absolutely, Mr. Planck. My effect, now known as the Raman effect, is the basis of what is now known as Raman spectroscopy. It is used in medicines, forensics, and chemical analysis. It is used to detect diseases, to ensure drug quality and in investigating crime scenes, all without damaging what's being tested.
Incredible. So light is no longer just receiving, it helps us understand math concepts.
Exactly. From hospitals to labs, its applications are everywhere.
I think it all started with the curiosity about the color of the ocean. As for my theory, it gave birth to the modern day science of quantum mechanics, a concept that is today used in lasers, semiconductors, LEDs, MRI machines, and even the microchips used inside our phones and computers. Even the atomic clocks used in GPS systems run on quantum mechanical principles. And to add on, the newly emerging technology of quantum computing that is revolutionizing how computers solve complex problems.
It's amazing, Max. What began as a fix for an equation became the basis of modern technology.
And this simple shift in life now helps doctors, scientists, and detectives every day. Perhaps that's what science truly is. Not just helping people understand the world, but giving people the tools to change it.
Well, that marks my time here. It was a pleasure meeting the father of the quantum theory.
And an honor to meet one of the pioneers of Indian physics.